Hi dear students, welcome back to my session. Today we are going to discuss a few more problems on the nodal analysis. Last class we discussed about the nodal analysis, few techniques, few cases. In this session also we will discuss further cases by using nodal analysis. Let's move to the next slide. So in this session, in our last session we discussed case 1 with the independent current sources, but in this session we will discuss case 2, circuits with independent voltage sources. How the nodal equation will be exits if I have independent voltage sources. Let's see by using this problem. Right, if voltage sources are connected to the reference node, what's happened? How the nodal analysis will be going to be performed by finding the particular current through that branch of 6 ohms, 6 kilo ohms. So the problem is here, find I naught by using nodal analysis. Here I naught is this one, sorry. Here I naught is this one. This is I naught. From here, if you observe the circuit diagram, this is 12 volts and this is 6 volts. Please observe the signs. This is positive and negative, and this is negative and positive. My current is downwards. You should not change the directions which is given on the problem. If he doesn't given the any current directions, you need to be assume either maybe upwards or downwards based on your interest. But if you given the indication of the current directions, you must follow that types of that direction only. Right, let me move to the solution. In the solution, right here, first we need to assume the essential nodes. Here v1, v2, v3 have the nodes v1, v2, v3, and this is a reference node 0 volts, right? 0 volts is a reference node. If you take this is for the finding of v2, you should depend upon v1 and v3. But here, luckily, we know the value of v1 because instead of finding v1, this value is directly is given. So that what I explained in the theoretical mode. We do not need to apply the KCL at node 1 because the node voltage at this node is now this is 2 volts. Again, I am going to be repeating. We do not need to apply the KCL at node 1 because this is the node 1. We should not apply it because KCL means the current. If you, as per the law of nodal analysis, currents always living from the nodal voltage, from the assumed nodal voltage, right? From the assumed nodal voltages. Then, but here it is doesn't require to apply the KCL again at unknown nodal voltage because the unknown node voltage is known value. Then V1 is 12 volts, V3 is 6 volts. That what I explained in critical mode. We do not need to apply the KCL at node 1 because the node voltage at this node is now. Also, we do not need to same rule is applicable for the V3 point. We do not need to apply KCL at node because the node voltage at this node is now. Here we used to follow the minus V3. If you observe V1, the living sign is minus 12. The living sign is here plus 6. You can follow living sign or you can follow starting sign. Here V1 is positive 12. Here V3 is minus 6. Notice that V3 is negative because its polarity is opposite to the polarity of voltage source, right? Polarity opposite to the polarities of voltage source. If this is polarity is positive and negative, this is exactly opposite now. If you taking the polarity of V1 positive, this is negative, this is positive, and this is negative. After based on your assumption positive and negative, this is similar denotation of 2 volts. Then the V1 will be plus 12 volts. But here your assumption and your reference given 6 volts is exactly opposite direction. That means V3 will be minus 6 volts. Hope you understand. In the previous session we solved that type of problems. Please, if you any doubts, please go through that session. right? Next, then the negative sign of polarity is the reference node. Now we have to only one unknown node voltage, that is V2, and we know the V1 and we know the V3. Let me draw this diagram in our paint, then we can understand easily. Right. 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 9 volts. Now here this is V1. Already we know the value of V1 is how much? Plus 12 volts, and we know the value of V3 how much? Minus 6 volts. Minus 6 volts. And V2 is unknown now. That already you given the indication of plus and minus. V2 is unknown now, right? So plus and minus pluses. So you need to be find this V2. For the finding of V2, you should depend upon this 2 volts. So hence, at node 2, just apply the KCL. Just apply the KCL because current is leaving from this unknown node voltages. Let me take these currents are I1, I2, I3, right? 1, 2, and 3. So now write the equation based on this direction of currents and this signs. V2 plus V1, sorry, not plus, V2 minus V1. V2 minus V1 by 12K, because here the leaving sign is negative. Na? V2 minus this one is this current. So this I1, for the finding of I1 current, you should go till this point. So V2 and V1. So no need to be find this. This is already the value is given itself. So you should go for this ground level, for this reference point. Then only you can know the this current directions, right? Or you know this value V2, if this is positive and this is negative, the leaving sign is the potential difference between V2 minus V1 means positive, means V2 minus V1 means potential difference between 2 points. Then the value will be V2 minus V1. V1 is nothing but a 12. V2 minus V1 by how much was 12K, plus what about second current I2? I2 is V2 minus 0 by 6K. V2 minus 0 by 6K, right? Then what about I3? I3 is V2. Let me write minus itself only if you want to take that is in positive way, or you can take directly V2 plus 6. You can write, if you can write in two ways. One is if you go till this 6 volts, or you can depend upon V3 itself, because V3 is nothing but 6 volts now. So that is the reason you can go for with the reference of this 0 volts, or you can go with the reference of V3 only. But both the equation are same. So let me try for the writing of in two ways. One is, let me write in this way. First way, V2, first way I am taking the reference till 0, means for the flowing of current through 0, it will include the 6 volts itself only. So V2 plus 6 by 12k, or you can write V2 minus V3, because this is V3 only now. V2 minus V3, it doesn't matter how much voltage is V3, is a plus or minus, that will comes under your next step. First you need to be differentiate of these two voltages. Then you should write V2 minus V3 by 12k. But here V3 is nothing but how much value? Minus 6. Then minus into minus plus. Then the value will be plus 6 volts. The same value is same, right? The both the way is same. V2 plus 6, V2 plus 6 by 12k is equals to 0. So this is the only unknown node voltages of V2. Already we know the known voltages V1, V3, but only one voltage is the pending, that is V2. So after this equation, same similar to this. So after solving this, you will get V2, right? You will get V2. V2 how much? 3 by 2. After solving here the only unknown parameter only V2 now. So then if you solve the only mathematical algebra and mathematical reduction techniques, then you will get only unknown parameters, that is V2. V2 is 3 by 2, means 1.5 volts. So now let me write that. Now write me. So let me write that. Right. So now you got this V2. V2 how much? 1.5 volts. Now you got V2, means this voltage. V2 is across this 1.5 volts. Then what about current? I is equals to, as per the law of ohms, I naught is equals to V2 by 6k. 6 into 10 to the power of 3. Kilo ohms is 10 to the power of 3. You should remember those prefix terms. Already we discussed in our first classes. V2 is nothing but a 1.5. 1.5 divided by 6 into 10 to the power of 3. Then you will get, do one calculation. 2.5 to the power of, which means 0.25 milliamperes of current which is flowing through this, 6 ohms, 6 kilo ohms resistor. 0.25 milliamps. I naught is, then you need to draw the final circuit by mentioning this unknown branch currents like this direction. I naught is 0.25 milliamps, like this. You should denote clearly. So this is one type, one case. In case 2, this is one type of problem. In case 2, we have another way of expression, that is comes under the bay category. If the voltage source are connected between two unreferenced nodes. So let me think in that way. In example number 4, means like this: if the voltage source are connected, find the node voltage of the following circuit. If the voltage sources are connected between the unreferenced node, because for this the reference node either maybe this or this, or if you taking this 4 is the one of that is a reference, because this is 4 are connected to the common point. So the reference node are placed here. But here if you take this voltage source, this is connected to the unreferenced nodes. Then in this types of situation, how my nodal analysis is going to be applied? So let me think. So just observe the circuit clearly. Here there are a lot of voltage source, lot of active sources, means 3 current sources, 1 voltage sources, and rest among the rest of the elements are comes under the passive category. So let's think. Let's move to the solution. Please observe the directions and observe the signs. Right. Here, uh, first add the essential nodes. Here the essential nodes are V1, V2, V3. This is not essential node because this is only a corner point, means this is only one direction of current. So you can draw like this. You can apply mesh analysis, or you can apply loop equation based on the loop currents. You can apply any of the technique for this, but here in this particular method we are going to be applying only nodal analysis. Since we cannot express the current through the voltage source in terms of node voltages, we combine the two nodes 2 and 3. This one we combine. Let me draw this clearly. Right, we combine the two nodes, that is 2 and 3, means V2 and V3 as a one super node, as shown in figure below. So here this is a super node. We are going to be merging of these two nodes is super node like this. Means here we cannot express the current through the voltage sources. The current flowing through the voltage source we can't express, right? We can express the current flowing through only the passive elements, either maybe resistive, inductive, capacitive only. We can't express the current through the voltage source, because voltage source will comes to the picture when the resistance or when the resistive load is if your resistive load is connected across to them or are connected to the series to them, then only the voltage sources comes to the picture. Otherwise there is no drawing of voltage from that source. So right, so by remaining that points, so we should not express the current flowing through the voltage source. That is the reason I'm taking these two nodes into the one common node. That common node is nothing but a super node. So I relate to one of the node voltage V2 or V3 in terms of one as follows. If this is V2 and V3, right, for the measuring of the voltage between V2 and V3, how you are going to be right? V2 minus V3 is equals to 22 volts, or V3 minus, because V3 is positive, V2 is negative now. So that is the reason I am taking V3 is positive, V2 is negative, and this is a 22 volts. So you can write in that way. That is super node. I'm taking only V3 is because V3 is connected to positive terminal and V2 is connected to negative terminal. Then V3 higher potential to the lower potential, V3 minus V2 is equals to 22 volts. Then if you want to know the V3, then it will be V2 plus 22. It comes under to the positive way, means higher potential is always higher than the lower potential V2. Then this supernode is now apply the KCL at supernode. Now let me apply this KCL as supernodes. Just observe this 1, 2, 3, 4, 5, 6 to the points in indicator above figures. So now I am going to be applying the supernode. So V2 minus V1, right? Then V2 minus V1 by 1 by 3. This one V2 minus V1 by 1 by 3, V2 by 1, this one, V2 by 1, next this is minus 3. So now you're going to be apply for these three currents, 1, 2, 3, and this supernode currents is this one. I'm going to be adding up these three currents. Then V2 minus of, wait, V2 plus 22, then I am adding one more, apply at KDL node 1, right. Then V2 plus 22 by 1 by 5, this one, V2 plus 22 by 1 by 4, and V2 means this one, V2 plus 22 minus V1 by 1 by 4, then V2 plus 22 by 1 by 5, right? This one up to here, this one. Then what about the 25? It will comes to here. We have 4 branches connected to the node 1. Let me think. Node 1. This is node 1. 1, 2, 3, and 4. So here what I want to try to tell is, for the doing of this V1, V2, V3 separating of three nodes, I am converting this V2 and V3 into the super. After converting this V2 and V3 into the one common node, means either maybe V2 or either maybe V3, or you can write instead of V2, you can write V3, sorry, V2 is equals to V3 minus 22 also. Here you can write V3. So that comes under the completely V3 category. So here I'm converting these two nodes into the one unknown parameter, that is V2. Here V2, here V2 plus 22, because V3 is nothing but a V2 plus 22. That is the reason I wrote directly. Now I applied this elliptical part. I applied the nodal analysis technique for this path only. While I'm applying this path, let me take this screenshot of this. Then you can understand clearly. Should wait. Right. Right. Now observe carefully. If you see this, if you see this path, I'm taking the making the unique path between V2 and V3 by converting V3 to V2 plus 22. I'm taking this is called super node. Means this is completely one node. This complete one node. This is one node. So now I have only two nodes. Two nodes, two unknown node voltages. Right? So based on that, I'm writing this equation. So this is completely one node, one very big node. I can name it as a big node instead of super node. This is very big node, and this is one more small teeny node. So with this two unknown nodes, you are going to be write the loop, the nodal analysis equation. So let me write for the equation for this first loop. For this, I'm going to be writing. So these are the currents which are flow through this one current, two, and this is one more, three. This is one more, four. There are four unknown currents which are flowing. I thought those are unknown. While my flowing through the directions, I can find it out either that is comes under the unknown category or known category, right? So first, let me find from this. This is 8 amps. So finally, this is not unknown currents. This is a known currents because this is 8 amps already given for this. Hence, that my assumption direction and the problem given direction is same. Then instead of writing the positive, instead of writing the negative sign, I'm going to be writing the positive sign. If when the negative sign comes, if this direction is opposite to the my assumption direction, then that will come into the negative category. Now I'm going to be writing this positive 8. Here you need to be mention wording. What wording you need to be mentioned? Applying the KCL at unknown node voltage is V1. Then you start writing of this nodal analysis equation. Right, plus 8. Then what about this? This is one current. This is 2. This is 3. This is 4. There are 4 currents which are living from the unknown node voltage, that is V1. Right? Hope you clear. Please concentrate here carefully because this is super node. You will get confused. Then this 8 amps, then it will becomes V1 plus V1 minus V2. V1, I'm writing the second current, V1 minus V2 by my resistance 1 by 3. Then I'm writing the third current. This is third current. Third current, oh, by default it is given. So now it is noun category, comes into the noun category. This is not unknown current, branch current. This is noun branch current, that is 3 amps, because plus 3 amps, because my assumption direction is and my given current direction is same. Then it will be 3 plus then what about this? This is very big line, v1 minus v2 plus 22, v1 minus v2 plus 22, because this voltage is v2 plus 22. Instead of v3 we are writing v2 plus 22 by how much value of resistance? 1 by 4 is equals to 0. This is one equation. So let me check this equation. Plus 8, v1 minus v2 by 1 by 3 3, and v1 minus v1. So this is the way of writing the equation if you are taking the super node. Then v1 done. What about v2? Let me write for the v2 also. So now v2 also have, this is common, right, for this. So for this you need to be write many currents. Let me draw those many currents. So here from v2, this is the current direction 1, this is a 2, this is 3, this is 4. From here again 1, 2, 3. So you will get total 1, 2, 3, 4, 5, 6, 7 parameters. So let me check here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Where is 7? So you should come to the 7, right? So sorry, this is not, because here this is you converted into the super node, right? So you should not consider this is, because this is comes to the super node. Let me erase that. Let me erase that. Only these are the current, these are the super node. You should not include this. V2 and V2 should not draw the current between V2 and V3, because already you are converted that V3 into the V2. Right? These are the total. You will get 6 unknown currents. Then start writing with the reference of V2 node. Then in the same equation itself will add this V2 plus 22 also. Right? Now let me write. Let me take this is one current, V2 by 1. First equation, V2 by 1, V2 by 1 plus next V2 minus V1. This, please observe this blue line, V2 plus V2 not plus V2 minus V1 by 1 by 3. Next, what about this current direction? Is exactly opposite to this direction, and then it will comes under the category of minus 3 amps, right? Next, I am done with this part. These three blue lines done. I am done with this 3. Then let me move to these 3 blue lines with three blue outlinings. Sorry, outliving currents. So not outliving, living currents from this V2 plus 22 branch. Then now let me write this equation. Plus V2 plus 22, V2 plus 22 by, this is V3, right? Instead of writing V3, I'm writing V2 plus 22 by 1 by 5. 1 by 5 plus, let me find this current. The current is always already is given, is a 25, exactly opposite to my assumption direction. Then it will become a, instead of minus, plus, sorry, instead of plus it is minus 25 amps. Then only one branch is left, that is this branch. Then I'm writing V2 plus 22 plus V2 plus, means instead of writing V3, I'm writing V2 plus 22, because I converted V3 and V2 into the super node. V2 plus 22 minus V1 by my resistance 1 by 4 is equals to 0. So this is very lengthy equation. This is very lengthy equation. You should, if you observe this equation, you have only two unknown parameters. One is V1 and V2. In this earlier, this equation with reference of V1 also, we have unknown node voltages. One is V1 and V2. If you solve those unknown node voltages by framing the mathematical reduction techniques, then you will get V1 and V2. Then you will get unknown node voltages V1 and V2. Please observe this here carefully. V1 is minus 1 minus 4.5, V2 is 15.5. After you are getting V2, if you substitute the V2 point in the V3 super node, you will get V3 itself. So V3 6.5, V2 minus 15.5, and V1 minus 4.5. This is the way of solving the, if voltage source is connected in the with the unreferenced nodes, right? Hope you clear. So some extension of our example number 4. He's asking current flowing through this particular IS. Then how I am going to be doing this? So just observe this. In previous example, find the current through the 22 voltage source, which is given between presence between V2 and V3. So we assume the direction of, so for this finishing of this problem, you need to be draw the final circuit. I forgot to tell you, but that is my duty to tell you. You need to be draw the final circuit by representing V2, V1, V2, and V3 minus 4.5, minus 15.5, 6.5. Instead of writing V1, V2, directly you need to be write this with this voltages, right? So continuation of example number 4 by finding the current through 22 voltage source. We assume the direction of the current I shown in below. Please observe the direction. This is my assumption. If his current is not given, if he asking it just in wording without without this showing the direction, if you mention the wording, then you can take any direction, but I'm taking the direction from left to right because I used to write from left to right now, so that is the reason I'm taking the left to right only. We assume the direction of current as shown below. You can assume the opposite direction if you're interested. Then we can apply the KCL at node 2 or node 3 for the finding of current IS. You can apply KCL at node 2 or node 3. Now I am applying the KCL at node 2. Please look at here. Now I am applying the node 2 V2. Here I am applying, these are 3 currents, 3 not 3, 4 currents, 1, 2, 3, 4 currents will comes to the picture. 1, 2, 3, 4 currents, 2 unknown, sorry, 3 unknown currents, 1 is known current, that is minus 3, because this minus 3 is opposite direction of this my assumption current. Then V2 minus V1 by 1 by 3, right? V2 minus V1 by 1 by 3, then V2 by 1, then V2 instead of writing V2 minus V3, you can write this current direction already is given. This current direction is similar to my assumption direction, hence it will be plus IS. Then here already I know the V2 and V1 value. If you substitute this V2 and V1, sorry, if you substitute this V2 and V1, V1 already you got the V2 and V1 in our previous problem, minus 15.5 and V1 is minus 4.5. If you substitute those values in this equation, you will get IS. IS is 15.5. Or you can, if you want to apply for node 3 also, you will get same answer. But here you will have the lengthy equation compared to this V2. So V2 plus 22 here, these are two types of equation, 1 by 4, 1 by 4. It will some lot of mathematical practice is required for the solving of this types of problems. But if you always try to solve in try to write in simple equation. Don't try to solve your problems in complicated equation. That is very hard for you for the solving in examination point of view, right? So here V2 plus 22, same equation. If you can write this is V3. Instead of writing V3, it is the value is V2 plus 22. Already you assumed. Don't write again V3. It is V3 is nothing but V2 plus 22. So that is V2 plus 22 minus V1 by 1 by 4. V2 plus 22 by 1 by 5. It is exactly opposite direction of my assumption. Then minus 25. Same equation will come. And my current direction is also opposite. Right? This is current direction, my assumption. This is my problem given direction because my assumed in the assumption. So IS will be opposite direction, then the is will be minus. Then the value will be, after solving the mathematical things, then it will get 51.5. So these types of problems may comes to your examination point of view. This is very super node means topmost problems in nodal analysis technique. Most probably this problems comes under your in your graduation level, but as of now, this is very important for the knowing of some basics. Let me see some extra problem here. So you can observe this problem. Find the node voltage. This is very simple problem. Already you know. Let me have a look very fastly. So write the node voltage equations. If you want to write only node voltage equation, here you can get unknown node voltage by directly here. This is V1, V2, and V3, and this is reference node. In order to find the current in 1 by 6 ohms, this 1 by 6 ohms, we assume the node voltage Vx between the voltage source and 1 by 6 ohms means this. We have there 1, 2, 3 voltage source between this 1 by 6 volts, right? So hence I'm going some reductions. Node voltage Vx between the voltage source and 1 by 6 ohms, between the voltage source 2 volts and 1 by 6 ohms, as shown in figure below. The relate Vx means this one. I'm making one point here, Vx. Sorry, here Vx. Vx between the voltage source and the 1 by 6 ohms. Relate Vx. This is a Vx. Vx is nothing but if I take this higher potential minus lower potential, or you can write V3 minus Vx is equals to R. You can write, because V3 positive, Vx negative, then V3 minus Vx is equals to R. You can write, if you want to know the write the Vx in terms of V3, then it will be V3 minus 2. Now we can easily apply the current through the voltage source and 1 by 6 ohms resistor in terms of node voltage V3 minus V2 and 2. Right? Hope you understand what I'm trying to say. So here you can apply easily node voltages, because here the 2 voltage source, here the voltage source here itself is given, and for this also is given for the voltage source. For making of lot of confuse of this two voltage source, then I'm making one point, assumption point, in between 1 by 6 ohms and 2 volts is a Vx. I'm naming Vx in terms of V3. Then the point is V3 minus 2. Here the voltage is V3 minus 2, here V2, here V3. Hope you clear. Now I am writing the node loop equation, sorry, nodal equation or KCL. Applying KCL at node 3 means here. See, observe carefully of the writing of this equation. The direction is given same, but here the value of gain minus 25. Then you need to be write the same value minus 25. Then what about this V3 by 1 by 5 clear. Then what about this V3 minus this, let me write V3 minus V1 by 1 by 4. Then the final picture comes to the here V3 minus V2 by 1 by 6. If this is not mentioned, I will repeat it. If this is not mentioned, then V3, what about this 2? V3 minus 2 minus V2 by 6. Same comes to the picture, right? If this point is not mentioned, how we are going to be write this equation? I will tell you. V3 minus 2 minus V2 by 1 by 6. Same. I will show you clearly. Don't worry. If that V3 point you forgot to mention Vx, you don't need to be assume of Vx. You can write directly. I will show you. Wait. Right. So here, for the writing of nodal voltage equation, you should remember many very important points. You should always follow the leading side, right? So from this, so this is current direction. For this is the current mesh 1, 2, 3, and this is 4. Right? For this, you can write for this V3 by 1 by 5. You are very clear for this V3 by 1 by 5. Then what about this? This is also very clear because you need the same direction, even though that is showing in minus 25. Then you can write minus 25 directly. 25. Then this 2 done. Then what about this V3 minus V1? Because this is V3, this is V1 by 1 by 4 plus V3 minus V1 by 1 by 4. Then the final current is comes to the picture. This current which is flowing through from V3 to V2. While the flowing through the V3 and V2, you need to be always follow the leaving sign. I used to say this point is in very frequently. So here for the writing of V3, you should depend upon you're starting from V3, right? The leaving sign of V3 is positive V3, and for this battery the leaving sign is negative minus 2 volts minus 2. Then this resistance is come to the denominator, right? For this V2 is negative minus V2 by a resistance 1 by 6, or else you can write, I will show you by drawing this point here. This is minus plus and this is V3. What I'm trying to say, without mentioning Vx, also you can write this equation directly. This is V2. The signs are very important. Here this sign is positive and negative. This sign is positive and this is negative. The resistance sign is doesn't matter while you're writing the nodal equations. Right? Always very important of the signs of voltage sources. So this is 2 volts, right? This is 2 volts. Now my current is flowing through like this. From this, while the flowing of current of this, I am writing the current equation I is equals to in terms of V by R itself only, right? So for the for numerator, I need to be considered as a V. For the denominator, I need to be write resistance. So for the writing of numerator, how my current is traveling? From this, my leaving sign is positive plus V3. I always used to follow leaving sign from the day one. I set the rules. No need to repeat again. The leaving sign is V3, and for this voltage source, the leaving sign is plus 2. Right. Then this resistance will come to the denominator. No need to be worry about the numerator. Then my leaving sign of this voltage source is minus V2 by 1 by 6. This is the way of writing of these equations. Hope you clear, right? Same comes to here. V3 minus V2 minus V3 minus 2 minus V2 by 6. Same. V3 minus 2 minus V2 by 1 by 6. If you solve this equation, you will get V1, V2, and V3. Right. Apply KCL at node 2. Then you will get one more unknown equation like this. Then apply KCL at node 1, or already you will get you know the writing of node 1 equation, node 2 equation also. There's some tricky about this V3. That is the reason I included this example in the class. So hope you clear, right? And so try to practice more problems. This is not comes under your examination, but this is not your syllabus. Dependent sources comes to your in your graduation level. That case 2 is enough for you guys. Till case 2 is enough as per your diploma syllabus. I hope you clear about this session and these problems. Thanks for your patience. We will meet again. Bye bye. Have a good day.